Howdy, everybody. This is Module 3. We're getting ready to start Module 3 of Introduction to Astronomy. One of the things we're going to be doing is looking at the contents of our solar system, not just our star, but the planets that wheel around it. One of the little interesting facts that if you take a look at the total angular momentum, velocity times the distance from the center of the solar system times its speed, okay, okay, that of the most of the mass and most of the angular momentum of our solar system is tied up into two places. One is the spinning of the sun on its own axis and Jupiter. And so you could very conceivably take and describe the the solar system with Sol as its primary star, as just a single planet with a dusting of other small terrestrial rocks and maybe some gas globules. So Jupiter is the 800-pound gorilla in the room. We think that one of the reasons why Earth was suitable for life was in part because it wasn't bombarded during the early formative stages of the planet. And the reason is because Jupiter was out there vacuuming up all the spare debris. Any of the planets that had excess hydrogen and helium, excuse me, summer cold, excess hydrogen and helium in the inner system. Early on, the light pressure just boiled that off. It was just too hot to maintain those gases, and they were swept out into the outer solar system. And again, swept up by Jupiter, which got even larger. Um, I give you a couple in the announcement. I give you a couple of talks by Isaac Arthur about his Outward Bound series. Our last activity is going to be a discussion of colonizing other planets. And I give you a couple that I thought were interesting. One, because I hadn't really thought about them as colonization targets, but with sufficient energy and sufficient drive, the human race could possibly colonize the outer solar system and eventually the Oort cloud. Now, one of the great things about the Oort cloud is if by happenstance or circumstance, uh, maybe not even purposefully colonized, but maybe there will be marginal communities that will be forced out into these rarefied places like the Oort cloud. Will have this technological ability to go there, and then economic or political necessity would drive them out there. Well, the thing is that objects in the Oort cloud only very tenuously tied gravitationally to our star, Sol. It's more than conceivable that there's some objects out in the Oort cloud which are actually shared with our neighboring star systems. Okay, so just because something is colonized and Sol system in the Oort cloud doesn't mean that in 20,000 years it won't be in orbit of another neighboring star. And if we ever get to that point, man spreading beyond the solar system, uh, that's inevitable. That's inevitable because in 10,000 years, then we're in the neighboring stars. 10,000 years after that, we're in the neighboring stars after that. And in a few million years, we've got the entire galaxy covered. That's one of the reasons why we think that um, we may be the only intelligent species in our galaxy, or that the intelligence is very, very rare. It's because if you look at how rapidly on a galactic scale, cosmological scale of billions of years, how rapidly that colonization could take place, that spreading of life, that we should already be meeting them. If there are other technologically advanced intelligent species, things that are capable out there of making spacecraft, we should be meeting them by now. Anyways, so just back to the topic at hand, which is the contents of our solar system. We've got the rocky terrestrial planets that have lost all their hydrogen and helium and are just left with this little layer of oxygen and nitrogen in the case of the Earth and some trace gases for Jupiter. Not Jupiter, Mars, and then there's the hothouse of Venus, and the baked surface of Mercury. And then we move further out. Okay, we've got our two gas giants. We've got Saturn and Jupiter. Saturn, which you know for its rings, very temporary rings. Those will only last a few million years, and then they'll be gone. And perhaps another planet will have torn apart one of its moons, and that will be our ringed planet. Just something to think about. And then, so we've got our two gas giants, and then further out, we would probably refer to these more as ice giants. Okay, so Jupiter and Saturn are primarily formed of hydrogen and helium. Right. If we go just a little bit further out toward Uranus and Neptune, we find that these are made up of hydrogen ices. That hydrogen ice can include H2O, water ice, but it also includes frozen ammonia and other nitrogen compounds, hydrogen and nitrogen compounds. Um, just something to think about, okay? All right. I'm going to let you go. And if you have any questions, please don't hesitate to ask. Signing out.